So now I have a topic right in front of me called glucose. Glucose, I remember I did it under the category of monosaccharides. And what were my monosaccharides? They were those carbohydrates which cannot be hydrolyzed any further. So glucose is a monosaccharide. Now I will draw the structure of glucose. So I place these four carbon atoms in the middle, and I remember that I had an aldehyde group at the top. So I place an aldehyde group at the top, and then I place a CH2OH group at the bottom. Now these four carbons in the middle are all chiral. And what I remember is that what I have to remember is that I have to place OH and H group on these particular chiral carbons. What I do is, leaving behind the second chiral carbon, that is this chiral carbon, I place my OH on each of these remaining chiral carbons on the right hand side. So I've got an OH over here, an OH over here, and an OH over here. The OH on the second chiral carbon is actually on the left hand side, so I place my OH on the left hand side. Now I'm left with hydrogen, and I fulfill all the rest of the valencies of carbon of these chiral carbons with hydrogen. So I have got my structure of glucose, and this is how you remember it, that leaving behind the second chiral carbon, all of the OH comes on the right. Okay, and in the second one, it is in the opposite direction. Now, what do I call this? I call this the D glucose. Now, this D has nothing to do with the optical activity, that is the small DNL, dextro and devorotatory. This D here refers to the configuration. What we remember from the previous lessons is that OH group, whenever it is on the right, and I've got a perfectly good structure in which the functional group is at the top, and I've got the most oxidizing group at the top, most reducing group at the bottom. So the OH on the last chiral carbon, if it lies on the right hand side, it gives me a D configuration. So that is how I get the D glucose. So now I've got the name of this glucose, and it is D glucose. Next, what I do is, I see here that first let us mark all the carbon atoms that this one has in a straight chain. So I start from here and I call this one, then I go down and I call this second, the third, the fourth, the fifth. I stop here. Okay, now why did I stop here? Because what I'm going to do next is, I'm going to take the lone pair of these particular OH group. So this OH group, I'm taking the lone pair, and what these lone pair are doing is, they are gonna attack my CHO group, that is the aldehyde group. So these lone pair here are gonna attack this. Now, why am I doing that? Because now I'm done with the open structure of glucose, and now I want to draw the cyclic structure or the closed structure of glucose. So I notice two functional group. One is this CHO group here at the top, and this OH group. And what I do is, the lone pair of OH, I make them attack the carbon of the aldehyde to form a cyclic ring. Now, why am I not taking the rest of the OH groups, the lone pair of the rest of the OH groups? Because if I take this particular lone pair and I make it attack my aldehyde here, I get a six-membered ring. And my six-membered ring is a very stable ring. Please remember that. So I'm looking out for a six-membered ring. Okay. So what I do is that I now make a rough figure of what I'm gonna get. So I make a cyclic ring with six sides, and I have my O. So this is the sixth one, the sixth member of the particular six-membered ring. So I have my O here. Now, what happened was that here an intramolecular reaction is taking place between the two functional groups. So I have got an aldehyde functional group over here, and I have got my alcohol function group over here, and these two functional groups are involved in an intramolecular reaction, that is within the molecule itself. So we call that an intramolecular reaction. Now what this intramolecular reaction is doing is that it is depriving this particular OH. So this my OH here is getting deprived of a lone pair, and my C here, or this particular CHO, is getting rich of electrons. So what I can infer from that is that my oxygen here will get a positive charge because it is losing electrons, and of course it is attached to an H, so I've got an OH group. Now I'll name this particular oxygen as the sixth one. It is going to attack at the first carbon here, so the sixth and the first one are getting joined. So this particular line here is going to join the first and the sixth one. So what I'm going to do is I'm going to name this the first one. So this my here carbon is the first one. Now what I'm going to do next is that this CHO group is getting rich of electrons, and of course this pi bond is going to shift at the oxygen here. So what happens next is that my carbon here of this CHO, the aldehyde one. So what am I doing? I'm drawing my carbon of the aldehyde group at the first position here, and this O double bond O is now an O negative. Okay. So this is So I've got an H at the bottom also. Okay. So now here my O negative I'm getting from this aldehyde group because it becomes electron rich. Now what happens is we know that every atom wants to neutralize itself in order to gain stability. So what these two are going to do is they're going to exchange protons. Now what is exchanging protons? So this H here, if it leaves with a positive sign, it becomes a proton. So H positive is actually a proton, as you all know. And if this leaves with the positive sign and gets attached to my O negative here, then maybe there's a possibility that they'll neutralize each other. Maybe, not maybe, they'll actually neutralize each other because my O negative is going to be cancelled with a positive charge coming from the hydrogen. So what do I actually obtain now? Now I'm going to draw it in the main structure over here, and now I'm going to draw the cyclic form. Now in this cyclic form, as we have seen from our rough sketch here, my O was lying on this side, and now it is deprived of its H plus also. So my H is joining my O here, and I'm getting an OH group here. So these two are done with. Now, what I do is I start looking out for the numbering. And what I do is I know that this was my first carbon and this oxygen was the sixth atom of my six-membered ring. So now I can name the rest of the carbons and give them numbers. So I get this second, was my third, this was my fourth, and this was my fifth. Now, why am I doing this? Because now I'm gonna make my structure come from the left side to the right side, and this numbering is gonna be very, very helpful. Now, how is gonna be helpful? So, firstly, let us just learn what is gonna happen is that on my fifth carbon over here, I have a CH2OH group and an H group. My OH is already done with. I'm done with an intramolecular reaction. So I come next to the other two groups that were attached to the fifth carbon. So now in this fifth one, I see a CH2OH group and an H group. Now this CH2OH group I place over here, and this H group is left with, and it is here. So now I turn on to my fourth carbon. In this fourth chiral carbon, this chiral carbon over here, I have an OH and an H. I come back to my cyclic structure here, and I place my OH at the bottom so that it is at trans position with this CH2OH group that I had originally placed over here. So these two are trans to each other. Okay. Why they are trans? I'm going to explain it a little later. But you just see how I'm drawing the cyclic structure as of now. So I place these two groups at trans to each other. And now I complete this fourth one by placing an H over here. Okay. Now I notice that, and please you notice it too, that what I'm going to do is if I look at my third carbon here, this chiral carbon here, I notice that my OH is lying at the trans position with the OH of the previous carbon, that is the fourth one. So my third and fourth carbon are actually having OH at trans position. So I come back to my cyclic structure and I notice that I've placed an OH at the bottom here at the bottom. And now what I'm going to do is I'm going to place my next OH on the third carbon right at the opposite direction of the OH. So if this was at the bottom, now I'm going to place my OH at the top. So these two are also trans with each other. Okay, trans means opposite of each other in simple words. So I have my H left and I place my H here. Now also I noticed that the second and the third carbon which I marked, the OH are lying trans to each other. And now what I do is I place my OH trans to each other. So it was at the top and now I have an OH at the bottom here. So I've got this particular structure which I get after such a long time. And what I notice is so the fifth and the fourth carbon, the CH2OH group and the OH are trans to each other. Okay, this CH2OH group and this OH are trans to each other. Also, in the third and the fourth one, in this third and the fourth carbon, I have got trans OH in the trans places again. And now the second one also is in trans with the third one. Okay, so this is how I'm gonna obtain my cyclic structure. Also, I notice, okay, so I'm left with the first carbon over here and I can just place an H group over here in the left space. Now, what happens is this in the first carbon here, what is happening? A new chiral carbon is being developed. So if you see carefully, when I was placing my OH group, I was not very sure of where to place the OH group originally because here, as in all these, the rest of the carbons, I see a very clear relationship between the OH of one carbon and the OH of the second carbon. I can see whether they are trans to each other, and so I place them in the cyclic structure as they were. But if I notice the first carbon which we marked, that is this carbon here, I see that this carbon here is not the OH, the placement of the OH is not decided yet. So my OH can go to the top position also. That is, my OH can go to this position as well as it can go to this position because it is not fixed. And why is this happening? Because this is a new chiral carbon that is developing. So this is a new chiral center or a new chiral carbon. This particular is the new chiral carbon. So I here can place the OH group on the top and at the bottom also. So if I just start drawing so in the previous figure, I had what I originally did was I had my OH and my H here and the rest of them, I just fill it out for you. So I've got an OH, H, and this OH is in trans with the previous one. Also, my OH is in trans with the previous one, and I get a CH2OH group over here, H group over here, and here was my oxygen. So I've drawn this structure here, similar to this one here. This structure here, I've drawn, and I draw this. So I get this particular structure here. Now, what I said previously was that this OH can move from this position to here. Now what I'm going to do is I'm going to draw that. So here the main point that is I'm going to highlight is that my OH is shifting from this position. Now it is going here because it was a new chiral center which was developing and I'm not deciding. So the placement of OH is not decided and it can go from top to bottom. The rest of them remain the same because they are fixed in position with the placement of OH as they are trans to each other, the all of them. Okay, so now I have completed this and I can just see that I have placed my OH here in this one. So I have placed my OH is here and in this one my OH is here because the chiral carbon was not decided where to put the OH in that particular chiral carbon. So this is how you just draw the cyclic structure of glucose.